Okay, so today, you now know about me. My name's Tim. I love talking about tech, so if you see me around the conference over the next 4 days and I'm not asleep, come up and grab me and talk to me. That's what I do. I work as a DBA and developer at the moment at a UK university. I'm not student facing. They don't let me talk to students because I'll scare them. So I've spent 23 years doing Oracle tech, but never worked for Oracle. I've spent 18 years doing my website, oraclebase.com. So if you've Googled something and got there, that's what I do in my spare time because I have no life. I go home and play around with Oracle and write about it. As a result of that, I got invited to the ACE program and then subsequently the Developer Champion program that became the Oracle Groundbreaker Ambassadors. And I've got to go around the world talking about this, which is pretty cool. So, jumped straight in. Ooh, that sounded weird. Let's jump straight in. What are analytic functions? Has anyone used analytic functions before? Might have called them windowing functions. Okay, so what I'm going to do is try and break this down so that relate it back all the time to aggregate functions, because a lot of people get quite confused about analytics, but they've got a pretty clear idea of about what aggregate functions do. So I'll constantly refer back to that. It's just the easiest way I find to explain this stuff to people. So analytic functions were introduced in Oracle 8i. I believe Oracle was the first commercial database to do this. I could be wrong, but now you can get them in lots of other databases, and from MySQL 8 onwards, you also get them in MySQL. This is actually a little bit of a lie, but once again, it helps to explain what it is I'm talking about. Think of these as the ability to compute aggregate values, but without reducing the number of rows. And it's probably easier if I actually show you an example, a very simple example, and that will give you the idea of what it means. I'm not going to talk about syntax in this example, so don't kind of get scared if you haven't seen it before. It's really important with any Oracle statement that if you want the data to appear on screen in a certain order, you actually have a proper order by, okay? You will see order by all over the place in analytic functions, and it doesn't mean the data will necessarily be ordered that way. What it means is that the data set is ordered so the analytic function can be processed, and we'll see some examples of that. But let me just show you a quick demo so that you get a feel for what we're talking about. Ooh. Okay, so what I've got here is SQLCL, the little Java kind of replacement for SQL+, connected to Oracle Cloud running against the automatic transaction processing cloud service, so that autonomous database cloud service. This could be something running on your local PC. It's the same thing. Nothing I'm doing here relies on autonomous database, but I just thought it was kind of nice to use it rather than doing what we all do day in, day out. So first of all, I want to show you an example of a regular aggregate function. Here what we've got is select average salary from EMP. I'm guessing you're all familiar with the EMP table. What I've done here is got the average of the salary, and I've aggregated 14 rows down to a single row, and that's the average. So that's a really standard aggregate function. If I need a bit more granularity, what I can do is include a group by. So now I'm saying, give me the department number and the average salary. And because of this group by, I've now got the average salary per department. And that's exactly what I see. So remember those numbers, let them burn into your mind. We'll refer to them in a minute, but they'll be off screen. So standard aggregate functions, really simple. Let's have a look at a pretty basic analytic function. Don't worry about the syntax. Effectively, what I'm saying is do this, but give me the raw data. And I'll talk about the syntax in a minute. But when I run that, what I can see, I put a skip in there so it breaks the departments apart to make it clearer. But I've got all of the raw data from departments 10, 20, and 30, along with those average values. So I think that's probably the easiest way to visualize the difference between analytics and aggregates. They're kind of similar, but you don't actually aggregate the number of rows down to a lesser number. You still have access to all of the raw data. So let's start talking about what analytics really are. If we were to look in the manual, you'd see the basic analytic clause looks like this. You've got analytic function, whichever one it is, potential arguments, and then you have an over clause. The over clause is mandatory, and it's what turns this function call into an analytic call. But the analytic clause itself is optional, so you can just have over, open and close parentheses, and you've now got an analytic function. You'll understand what that means as we go along. The analytic function is made up of three optional pieces: a query partition, an order by, and a window clause. If we were to look at the manual for what these are, you'd see this. Partitioning clause looks fairly simple. The order by clause looks a bit more complex, and okay, that's pretty ugly. So I'm going to forget all that, and I'm going to try and liken this to aggregate functions to make it as simple as possible. So the first thing we're going to look at is the query partition clause. Essentially, this is group by for all intents and purposes. What we're saying is we're going to divide the row set that comes back from the query into groups or partitions. The important thing now is that the analytic function can only process within the partition, just like an aggregate function can only process within a group by. So what I can do now is have a choice whether to have the partitioning clause empty, which means treat all of the result set as one big partition, or break it down into individual pieces. So let's have a look at an example of that. It's really bad to have scripts with long names when you've got to type them in front of an audience. I can feel the performance anxiety building as I... So the first thing we're going to do is a very simple example. I've got employee number, department number, and salary, so the raw data from the table, and then I've got the average salary over nothing. Remember, an empty over clause is valid. What this means is I want to treat the whole result set as one big partition. There's no ordering, there's no windowing, anything like that. And so, not surprisingly, I get the whole result set coming out, and I get the individual raw data as well as an average for everything. If I want to start making this more granular, similar to the group by, and make it like the example you saw before, I can say average salary over partition by department number, and this is effectively like saying group by. So now the analytic function is constrained by the individual partitions, and we get that average per partition. So it's kind of quite simple. I think the partitioning clause, as long as you think this is effectively group by, everyone's happy. It should be pretty simple. The next thing to consider is the order by clause. Now, this is not surprisingly ordering the rows within a partition or the whole result set if it's not partitioned. Why does this matter? Well, some analytic functions are order sensitive, so the order of the rows actually matters, and we'll see that in an example. If I'm doing an order by, Oracle assumes I mean ascending unless I tell it descending, and the way it handles nulls is if it's ascending, it assumes I mean nulls last, but I can tell it to put nulls first, or ignore nulls. If I'm doing descending, it assumes I mean put nulls first, unless I tell it to do differently. So remember that point about the order by clause is just for the analytic processing. It doesn't necessarily affect the output of the query. So just keep that in mind. So the other interesting thing to consider is that I can have multiple analytic function calls in a single statement. So the data might have to be ordered in different ways in order for each of those calls, which is another reason why you can't rely on it to produce a specific order of data coming out. It's just about the order of the data when the analytic is applied. Okay, so first thing we're going to do is say first value. What first value does is it grabs the first value it sees, so it's pretty order sensitive, okay? We really need an order by for this. So in my head, what I've thought is I want to get the worst paid person out of this. So if I grab the first value in each department, I'm going to get the worst paid person. Awesome. So what I've done is give me first value, ignoring nulls, partition by department, and I'm super cool and, oh, that's failed abysmally. Right, so what's happened here? Well, we know first value is order sensitive, and I've not ordered the function call. So what I've got is literally the first value that came out, not the lowest value. So it's important when you have an order sensitive analytic function, you actually include the order by. What I should have done is this, where I said order by salary. In this case, I've explicitly said ascending with nulls last, but that's not important, that's the default. So now what I'll get is an ordered set within the partition, and first value will keep hold of the first one it comes across. So now what I get is the lowest value in each group. So first value, order sensitive, I must have an order by. But just to prove to you I can have multiple calls, what I've done here is I've done first value, order by salary ascending, and then first value, order by salary descending in the same call. So what I've actually done is the lowest paid person in the department and the highest paid person in the department, I've captured their details, their salary. So what I've got is all 14 rows, the raw data, including the individual salaries, but I've also captured the lowest paid person in each department and the highest paid person in each department without reducing the total number of rows. So it's really kind of cool when you're doing reporting and comparing things like, for example, where do I fit into the pay scheme? This is really easy, a lot easier than doing this programmatically. I started my time in Oracle 7, and I used to have to write PLSQL that tracked old values and new values and tried to put it all together. It was really annoying. This is super easy. So the last thing I want to talk about in terms of syntax is the windowing clause. Now, this tends to freak people out at first, but there's two things to say about it. One, as soon as you know what it's doing, it's pretty easy. And two, you'll often not use it anyway. So I would say maybe 1% of the time I'm using analytic functions, I actually specify a windowing clause, because most of the time I don't need to. But just bear with me. So what's the purpose of the windowing clause? It's to reduce the size of the window of operation of the analytic function. Remember I said that the analytic function applies to the whole partition or to the whole result set if it's not partitioned? Well, what we can do with the windowing function is actually reduce that size further. So if there's a need, we can actually say, I want this to be applied to a smaller subset of the rows in the partition. And we have an option of using range between, which is a reporting range. So that will be any rows that are within this range, irrespective of how many up or down the result set I'm going. Or rows between, where I explicitly say how many rows of data the window size is. So imagine a situation like this where I say my window is actually one row preceding and one row following the current row. If I were on the top of the partition, this is the current row, there is no preceding row, but there is a following row. That's the window of operation for the analytic function. If I'm in the middle of the partition, I have one row preceding, one row following. If I'm at the bottom, there is no following row, so I just have current row and the preceding row. So it's important to remember what this is doing in the context of a partition. How do we specify a window? Well, we have a few presets. So we have unbounded preceding, which means top of the partition. We have unbounded following, which means bottom of the partition. Current row, can you guess what that means? But we also have the ability to have either exact values or reporting values using preceding and following. The thing that tends to screw everyone over the first time they use this is this. The default windowing clause is range between unbounded preceding and current row. So as soon as you put an order by in, you get this. If you don't understand that's what it's doing, it can be quite confusing. And I'm going to show you a really silly example now of a mistake you could easily make, and I've made this, and why it's so confusing if you don't understand that. Okay, so what I've decided to do is I want to get the average of the salary per department, and I'm awesome, so what I've done is this, and I'm very proud of myself because I've just said, yeah, get me the average over the partition by department, and that's all cool. But what I haven't noticed is I've been a bit stupid and added in order by salary. Now, average isn't order sensitive, so this is pointless, but I thought I was clever, I'm going to add it in. What has that done? It's actually not given me the result I expected, because I was expecting to average all three of these and get that out, and it's actually given me a running average. That's because the default windowing clause is range between unbounded preceding and current row. So what it's done is said, unbounded preceding doesn't exist, average of one row. Unbounded preceding does exist, average of 2 rows. Unbounded preceding does exist, average of 3 rows. It's a running average. This might look a little bit strange to you. It's because it's range between, so it's actually, these two have the same value, so what we get is average of this, average of these 3 straight away, because it drops to the bottom of the reporting value, and then this is the same average again, average of all 3. If this were rows between unbounded preceding to unbounded following or current row, we would see that as a regular running average. So that's one silly mistake, and you get a very different result because you didn't know about the default windowing clause. The obvious solution is to remove the order by. We've seen that work. But if for some bizarre reason I wanted to keep the order by, then I have to make sure the windowing clause is correct. And what I might do is something like this. Range between unbounded preceding and unbounded following. And that then gives me what I expected. So I'm not suggesting you have an order by with average, but it does highlight the point that the windowing clause can be a little bit confusing when you start using it. And remember, as soon as you have an order by, you have a windowing clause. Okay, so currently what we have is these analytic functions available. So I'm going to talk ad nauseum about each and every one of them until your eyes start to bleed. What I'm going to do is pick a few of them that I find myself using repeatedly. Obviously, in your job, you may do other things, but I tend to find myself using a certain few of them all the time. Now, there's an asterisk next to some of them. What that means is they support a full analytic clause, the partition, order, and windowing clause. The ones that don't are typically because they don't need to. The job they do doesn't really rely on having that full clause. So it's not that they're broken or they're not up to date or something, it's just they don't need it. But you'll see that, so I thought it's worth explaining what that means. So let's just jump in and have a, Yay, come on. Let's just jump in and have a look at a few of them that I find myself using all the time. So we'll start with ranking. So you often want to apply a rank or a sort of number to a set of rows from top to bottom or bottom to top to say this is the top one or this is the bottom one. What use is a function called rank. So here we've got the raw data, rank over partition by department, order by salary. And what this is going to do is it's going to order the data in salary order and apply a rank to each row based on the salary. So effectively what we've got is Olympic medalling. Now in this case it's ordered by salary, so it's smallest to highest. So what I've got is in each department, number 1, 2, 3, notice what happens if I get a tie. It's probably better to look at this one. I get gold medal position, the worst paid person in the department. I'm not sure that's really gold medal position, but then we have a tie for position 2. So just like the Olympics, no one gets bronze. There's a gap, there's no third position, and then we get 4th position. So rank allows us to apply a rank to the data in a specific ordered set. If you don't like this gap, if you don't want it, then we can use dense rank. So dense rank does the same thing, but then it compresses the numbering so that we don't have Olympic style medaling. What we get now is 1, 2, 2, 3, 4. So it's no longer Olympic medaling, but we still have a rank. Why is this important? Well, often when we're reporting on data, we want to do things like top-end queries, where we say, hey, give me the top 5 or the top 1 from each department. Well, that's really easy to do, because what I can do now is say, here's the select statement I just ran, and I'm getting the rank out of it, and then I'm going to put that in an inline view, or maybe in a with clause if I wanted to, and say, just give me the values where they're number 1 rank. So effectively in this case, because it's ordered by salary descending, the top paid person in each department. And I get that. Now, because Department 20 has 2 people on the same salary, the top person is actually 2 people. Okay? So that sort of grouped top-end query is really handy, and ranking, whether it's rank or dense rank, allows us to do that. We also have a very similar situation with row number. So if you've ever used row num to limit numbers of rows, this is kind of similar, but it's processed as an analytic function, so it does actually understand the order of the data, unlike row num. Because if you say, and row num is less than or equal to 5, it's literally the first 5 rows you get, and then the data's ordered. So it's not a proper top-end query. It's very silly in Oracle. But what we can do with row number is essentially the same as rank, but it's no longer any form of Olympic medaling. It's literally a number from 1 to n for every row. So here I've got row number over order by salary. So what I'm doing is saying this is one big partition, the whole results set. Give me effectively a rank, but there are no concept of ties. So that's pretty straightforward. And of course, I can partition by department and get a rank per department using row number. But notice also that there is no concept of ties now. So if you need an absolute number of rows, then you'll probably use row number. Once again, this is really useful in a top-end type query where I can say, run that other query just, capturing the rank of each row, and then only give me rows where, in this case, they're in the top 2. So this is ordered by salary, so the top 2 is actually the bottom 2 people in every department. And these are the unlucky people. So any sort of ranking system, whether you use rank, dense rank, or row number, are really handy for those sort of top-end queries. Let me just remind myself what's next. List ag. Okay, so if you were to go onto my website, I've got an article called String Aggregation Techniques, and it's got about 6 or 7 different ways of doing this. Then in Oracle 11g, we got given list ag, which really made every other example pointless. With list ag, what we do is say, what I want to do is aggregate in this value, in this case, employee name. I want the separator to be a comma, that's the default, and I want this to be done within the group. So for example, here I've got group by, so it's not a normal analytic because it's based on the group. And I want the names to be ordered. So what does this give me? It gives me department number and a comma-separated list of employees. So virtually zero effort to get that. And if you look at some of the other alternatives to doing this prior to listag being introduced in 11G, some of them are quite complicated. So really useful thing I tend to use all the time. The next thing we've got is lag lead. Okay, lag and lead were the first things I ever used with analytic functions back in Oracle 8i days. And it kind of blew my mind because I was writing real-time control systems that controlled cranes and conveyor belts, and we were constantly having to look at previous and next values in a result set. So you had to just keep the rows and work your way down. It was really ugly. Then 8i came out and just thought, wow, I can just do this in a simple select statement. So let's have a look at that. What we've got is our raw data, salary again, but what I'm saying is give me the lag, look up the result set by one row. If there's no row there, give me back the default value of 0, order by salary. So I've got the result set, I've got my current row of data, but then I'm looking up one row to get the salary of the previous row. And lead looks down the result set and it's giving me the following row. So what we can do then is see that my salary is 800, previous salary doesn't exist because I'm the worst paid. The next salary is 950, and that's correct. I'm paid 950, previous salary is 800, next salary is 111. I've got a feeling that tonight's going to be a bad night. Not a good night. Okay, so lag and lead allow you to look up and down the results set. Really handy if you're having to do those running reporting of what's going on in a comparison. Luckily, that was the end of that demo. First value we've already seen. I'll show you that again though, and then show you a comparison to last value, which kind of sounds obvious but may not be so obvious for a different reason. Oops. Okay, so first value, we've seen this. Give me the first salary, ignoring nulls, over department number ordered by salary, so effectively the lowest paid person in each department. We've seen that already, that's cool. What I can also do is, and this is really only showing you for an example of something that's great and also bad about analytics. What I've done here is said, partition by department, order by salary, rows 1 preceding. So what this does is effectively mimics lag, because what I've got is, hey, give me the previous, the lowest value out of the current row and the one before it. Well, there isn't one before it, so that's the current row, but hey, this is me, and that's the lowest out of these two, and that's the lowest out of these two. So it's almost like mimicking lag, but by using first value and a windowing clause. One of the things that's kind of great about analytic functions is they're so flexible, but it can also make them very hard in the early days because you can often find 2 or 3 solutions to the same problem. And that can be quite confusing if you prefer to pick one and someone you work with prefers to pick another. So, you know, you've just got to add this to your tool belt and just keep playing with it until it becomes natural. But first value, you've seen that before, but there's a lot of variation with the windowing clause. Last value seems pretty obvious, and it kind of is, but there is a little bit of a gotcha. So last value, partition by department, order by salary. That's going to give me the highest paid person in every department, isn't it? Oh, it's not done that. Why? Well, I had an order by without a windowing clause, and we now know the default windowing clause for an order by is unbounded preceding to current row. So we get that situation where it's effectively a running total again. So if I'm going to use last value, I have to be sure that I have decided what my window of operation is. So probably in this scenario, what I needed to do is say range between unbounded preceding and unbounded following. That way I would get the highest paid person in the department, I would get right to the end of the partition and do that. So the gotcha with last value is you've got to understand the windowing clause, because by default it won't give you what you expect it to unless you understand the default. I often find myself not using last value but using first value with an alternate ordering. The only reason why this is a good idea, though, is that Oracle's pretty clever, and the optimizer, if it sees multiple analytic function calls with the same ordering, it doesn't have to reorder the data. So if you're already ordering the data, say, in ascending for a first value, it probably makes sense to do ascending again and use last value rather than order by descending and use last value. Otherwise, you've got two sets of ordering when you could get away with one. So even though I tend not to use it on its own, it's still valuable because you want to reduce the total amount of ordering that's happening because it takes time and effort. What else have we got? Oh yeah, okay, I'll show you an example of actually doing something vaguely analytical. So let's have a look at core. So what core does is a Pearson correlation, or a coefficient of correlation. And what this means is, for this particular test, if I get +1, it means there's a positive linear correlation. That means the longer you've been employed by the company, the more money you get paid. If I get a 0 out, it means there's no correlation. So it means there's no evidence to suggest that time served equals pay. If I get a negative linear correlation, what it means is that the longer you work, the less you get paid. So imagine market rate was shooting up and you were employed 10 years ago and you've just got a little pay rise every year. You're the worst paid person even though you've been there 20 years. It's kind of like that situation. So what we're going to do is use core to actually look at the data. So I've got the emp table again, not surprisingly, because it's nice and simple. And what I'm saying is I want to see a Pearson correlation coefficient of these two values. The amount of time served, which is sysdate minus the date you were hired, compared to salary. And I'm doing this on the whole result set with no partition. And what I can see is there's not really anything, if I look at the company as a whole, there's not really anything that outstanding. I'm getting very close to like no correlation. So there's no indication that pay is linked to length of time served in the company. So let's have a look at what happens if I partition the data up. So in this case, I'm saying, hey, let's do this comparison based on departments. So I want to compare how long you've worked to how much you've got paid on a department basis. And let's see what we see. Okay, in department 10, there is a very small positive correlation, but it's way off being 1. So I'm going to count that as being no correlation. Department 20, similar. Well, actually, no, it's similar. It's a bit worse. But notice how when we get to department 30 with the manager and a lot of salespeople, we suddenly get a much stronger correlation. So there does start to be something that indicates that the longer they've worked, the more money they get. Let's try it based on job instead of on department. So now what I've got is the same correlation, but notice partition by job. And what we see now is the way this works is if it can't really make a good conclusion because it's either an empty set or a set it can't make a conclusion on, you get a null back, which is why we've got those. What we can see is if we look at clerks, then there's actually a little bit of a negative correlation. So the longer they're there, the worse they get paid. But it's not that close to 1. But holy cow, if you're a manager, those people that don't understand what to do and shout at you a lot, then there's quite a strong correlation between how long you've served and how much you get paid. But if you're a salesperson, that correlation is a lot less, which I think is correct because salespeople are liars and therefore we shouldn't. Please don't video that bit. It's quite easy using analytic functions to start drilling into your data without having to have cool tools to do it. I'm not suggesting you do this rather than use cool tools, but this is actually at your fingertips, and this could be maybe an interactive report in Apex or something sitting behind on top of this query. You can get some quite good information out of it. And the important thing is this is done on the database. The data and this functionality is so close together that you're not wasting a lot of time. If you were either pulling all of this data into, say, Tableau and then ordering it, you've got a lot of network traffic. If you were trying to do this programmatically with PLSQL or Java or .NET, you've got a lot of loops and stuff to do. This is actually doing it in SQL. So I would do this at some conferences and people would say, no, I should do this in Node.js or something. And that's fine if that floats your boat. But to me, having this processing as part of the SQL ANSI standard, it just seems like a no-brainer. So one other thing I want to mention is a feature that appeared in 12c. It's not apparently anything to do with analytic functions, and it's a little bit syntax candy. So what we have is the ability now to say, from 12c release 1 onwards, give me an ordered set of data and say fetch the first 5 rows only. So if you've used MySQL and used the limit clause, this is like that. I don't have to worry about doing, say, inline views, ordering the data and pulling the data out. I can just do this. I also have the ability to use offsets, so I can page through data, have the ability to say fetch first 20% of rows only, things like that. So it's kind of nice. So why am I mentioning this in an analytic functions talk? Well, this is just syntax candy. You put this in and the optimizer does something with it. If you were to do a 10053 trace and look in the huge trace file that's produced, you'll find a section that says final query after transformations, and it shows you what the server's actually run in order to do that. In order to do that. And what it's run is this. And so what the optimizer has done is rewritten that syntax candy into an analytic function. So even when you don't know you're using analytic functions, maybe you are. I'm not suggesting that you should write this straight away, because that's super nice and super easy, and I'm happy that the optimizer is doing some of my job for me. But just so you know, analytic functions are being used all over the place. Another thing that's worth mentioning that appeared in 12c is another type of analytic function called match recognize. This is for pattern matching. You can go and see whole talks on this, so I'm just going to be very brief, but I do think it's important that you are at least aware of it. What does this do? It allows me to look for patterns in the data. So rather than very simple things, I might do something like, say, look for fraudulent transactions. What you'll see with things like betting or with, say, credit card type fraud is people often make a series of smaller interactions in a certain pattern, and some companies literally employ departments of people looking for this. So what we can do with pattern matching, and it looks a little bit scary, is we can actually define a few scenarios. So I've defined up as the units sold is higher than the previous units sold, flat is they match, and down is that the units sold has gone down. And then what I've done is I've defined a pattern here that is, the pattern starts and I'm looking for it to go up, flat, and go down. And this will find all occurrences of that in my data. So you might look for a specific thing like a small rise, a drop, a big rise, things like that. You can do that with pattern matching. The syntax is a little bit scary at first. It's a bit like the model clause. You look at it and just think, nah, I'm not going to do that. But once you get used to it, it's pretty straightforward. So once again, another type of analytic that might be useful for you depending on what you're trying to do. So in summary, I'm guessing I'm pretty close to the end of my talk. I hope I am, otherwise it's going to be a long question and answer session. Analytic functions, incredibly flexible. I like to think of them as being post-query processing. I started life as an Oracle Forms programmer, And so I often think of things back to that sort of scenario where, hey, this is my data and I want to do something for every row. It isn't actually doing that, but in my head, that's how I visualize it. Typically, this is going to be much faster than a programmatic version of doing this because you're so close to the data. Of course, every time you make something more complex, it's more work for the database to do, but it's probably better that that work is done close to the data than somewhere else. 5 minutes left. They're very flexible, which, as I said before, is a great thing, but also a little bit scary at times because there's always multiple ways of achieving it. But what will often happen with me is you'll see me on Twitter say something like, analytic functions save the day again, because I'd been doing something and just thought, I don't understand how to solve this problem with SQL. I'm just not good enough at it. And then my brain kicks in and says, oh yeah, there's a really easy solution to this with analytic functions. I do it and then go on Twitter and say, analytic functions save the day again. So if you follow me and you see that, you know that my brain has just kicked in. Okay. Like everything in life, it's all about the amount of time you spend with it. If today is the first day you've heard of analytics, you'll walk out the door and think, I don't know what that fat guy from Birmingham has been saying to me for the last 45 minutes. If you have been playing with them, they'll be easier. The more you use them, the easier they'll get. So just try and keep using them. Even if it's, I've got a good solution anyway, but I'll see if I can do that again in a different way just to get more familiar, because the more you use them, the easier it will get. So before I open up to questions, remember I have this website, oraclebase.com. I told most people at the start, it's what I do in my spare time because I have no life. There's a very plain page called oraclebase.com/workshops. On there you can see analytic functions, a developer's best friend, the PDF, the slides themselves, demo code that I've ran here, but more importantly, this article. I tend to have an article for every talk I do, but in this case, because it's mostly live demos, the article is really just links to all the individual articles on the functionality I've discussed, and that is the wrong one. Sorry. When I walked in, I thought I was doing a different talk today. Let's have a look. Whoops, functions. I suppose I could have really just used that link that was on the previous page, which would be more sensible. There you go. So actually this is a lot clearer because what you get in this article is, not surprisingly, everything I said today. So if I'd been nice, I could have shown you that and you wouldn't have had to sit through this listening to me. But if you're interested, search for analytic functions. I think if you Google analytic functions, this is what you get anyway. I think I'm top of the rankings for that. So, has anyone got any questions? Okay.
Could you tell me something about the CPU usage?
Okay. So the question was, can I say something about the CPU usage? Analytic functions is nearly always going to have some ordering involved. Ordering takes time, okay? So certainly, if I just do select star from table and compare that to something that's got even a conventional order by in, there's going to be an impact on that because the data has got to be sorted in order to apply the analytic function, assuming it is data that requires a sort, like an order sensitive analytic function. So effectively think of this as you've got as many order bys as it takes to apply the analytic function. So let's say I'm asking for order by salary, then that's a conventional order by in order to then apply the analytic function. If my query then has a proper order by at the very end, then that's another sort operation again. So I'm not trying to make out this is free. It's free in monetary cost, but it's not free in processing power cost. But the alternative is to pull all of that data out into the middle tier and do that crunching there, which involves network traffic and CPU there. If you happen to be processing in a way that you think that's more efficient because you've got great network and unlimited amounts of middle tier servers to crunch that, by all means go ahead and do it. But what I tend to find is it's a lot more efficient to do this at the database level. We've gone through this cycle where we've been told that doing stuff on the database is evil and the database is a bit bucket. And what is starting to happen a lot more is you're seeing people move back towards the database for some operations. There are some things that are very good in the middle tier and should never be done in the database, and some things that are very good in the database, and I think this is one of them. But there will always be an exception. I'm sure there are things that Google and Twitter do that this would not work for because they are not what I do, okay? So you always have to be a little bit careful about how you judge a piece of technology, because we're not all doing the same thing that Google and Twitter are doing. Therefore, their solutions are not necessarily appropriate to me. So yeah, there is a cost, and it's the cost of ordering the data. Anything else? If you're too shy to ask a question in front of the crowd, just come and grab me outside. I'll hang around for a bit, or come up to the front when we've finished. Thank you very much for coming and being registered early enough to come. Well done you. Okay, I've got a few talks this week on various things. If you're interested, what have I got? I think I've got them listed here so that I don't forget, even though I totally forgot this morning. Tomorrow I've got cool new features for developers for 18C and 12C. They're just things that I think are cool. I've got a 5-minute sort of slot in a multi-slot talk about a time that I destroyed my database but didn't get the sack, which is going to be fun. I'm on the beer demo for blockchain down at the Groundbreakers Ambassadors booth, so if you want to come and get free beer whilst listening to me talk about blockchain for about 2 seconds, between 2 and 4 tomorrow. And then on Thursday, I've got a talk about Docker. So if you're interested in Docker from a DBA perspective, feel free. If ever you see me and I am awake, prod me and say, I need to talk to you about X, and I'll do my best. If I don't know the answer, after 23 years of doing this and 12 years in evangelist programs, I'm pretty sure I know someone that does know the answer. So I'm happy to help. Thank you very much for coming. Enjoy the conference.